So since you're here, Keith.
Jack, I'll just give him an introduction here. So I would follow this crazy email list here with all kinds of things on it and see Jack's things. And I used to get enraged at his postings around 211, 212, 213, 214, because he was always saying stuff that I just was blowing my mind about. I would just come undone. And he would always propose something that I was partial to, but I knew it wouldn't work. And that is that you could modify the speed of light, you know, by putting in the C over N basically as the C for inside a medium. And the question comes, aside from it being invariant or not, the question becomes, well, why not? You know, that's what we do inside E&M. So why not gravity, just naively? And I was opposed to that idea for quite a while because it was clearly not invariant. The C goes to C over N replacement in the coupling constant, the G over whatever, 8 pi C to the fourth. Replace that C to the fourth with C over N. And Jack had a paper on that back, what, 211, Jack? Not a paper, but a presentation around 211, 210.
Yeah, that was at the 100-year Starship in Orlando that General Pete Warden, retired from Space Command, head of NASA Ames, invited me, you know, paid my way to give that paper. Eric Davis was there, and so was John Kramer. and I created a big stir because I started saying about UFOs, and they.
I remember I was there too. And
you were there.
I commend you. I commend you, Jack.
Yes.
You were obviously speaking prophetically.
Yeah, but the thing is, it's pretty funny that Eric Davis poo-pooed it, even though he's part of, you know, that whole Hal Puthoff to the stars thing, and. But in any case, that's where I first presented the idea that Keith is talking about.
Yeah, exactly, back then. And I remember seeing it in the email and seeing various aspects of it. And he made a good point. He said, well, we got this end of the fourth here, and everybody's doing this slow light business. And the slow light, you know, going down to meters per second. And just naively, you say, well, gosh, the index of refraction must be huge. And if you've got a refractive index of effective index of 1 million and you take it to the fourth power, you have a very large number enhancement in gravity coupling. So that's kind of interesting. That just hold that notion, regardless if it's correct or not, just the notion of being able to modify gravity. So that always got my interest and always bothered me, but it always also made me think in the background. And so eventually Jack figured out a way to make effectively a similar thing come true by proposing an invariant scalar in the coupling constant that turns out to reduce to that n to the fourth in the high end limit, basically. And I really don't want to steal Jack's thunder here, other than to say I became a convert. And I ended up switching from opposing Sarfatti to actually, well, by the craziness, the way things work out, I'm actually working with him now and supporting what he does. So it may turn out to be wrong, but it's a lot of fun, and I think it's very significant. And the good thing is he can make experimental predictions with this kind of model, and it may turn out to be wrong. That's all fine, but I like it.
But believe me, it's going to turn out to be right.
Well, I hope it's right, and that's like I say, I'm the biggest supporter for me to switch over to something that I think is really significant, because if it is correct, it is hugely significant. Okay, it's hugely significant, making orders of magnitude, many orders of magnitude difference in the index and the coupling of gravity with matter. And it allows you to do all kinds of things potentially if it's true. Okay, and I always have the if it's true, because we always have to do experiment and let it decide for us.
Yes, experiment has to decide. I agree. But what I'm saying is the tic-tac, the tic-tac, that's the smoking gun.
Well, let me shut up now. And I gave you the introduction, and now you speak. It's your talk.
All right. Well, you gave a very good introduction there. Why don't I just start taking questions? So why don't you guys ask questions about this, since Keith gave you the introduction. Okay, I'll make a few introductory remarks. Now I'm thinking about it. The important thing is that our coupling is totally invariant. Everything is consistent with the symmetry group of special relativity and general relativity. So the idea that it's not invariant, we have a scalar field. I mean, what Einstein's equation is, it's a tensor equation relating two symmetric second rank tensors. You know, the Einstein curvature tensor on the left-hand side, which Einstein called marble, you know, and then the wood on the right-hand side is the stress energy tensor of the source, whatever is creating the gravitational field. In our case, it's going to be just an electromagnetic field that we're interested in. And so the coupling has to be a scalar, has to be a zero-rank tensor. And when also when you use this, if the coupling is G, Brandenburg's Newton's G over the fourth power of the speed of light, if it's a speed of light in vacuum, okay, well, what is that? That is invariant only under special relativity. It's invariant under Lorentz transformations, okay? But depending how you define it, it's not really invariant under general relativity. You know, so what is invariant to general relativity is that you have a null geodesic. The interval is 0, but the actual speed of light, you know, depends on your transformations or your tensor transformations, the actual scalar speed of light. But in any case, what we have done is to introduce a scalar field. So we take the speed of light in vacuum, you know, that's like a calibration constant multiplied by a scalar field, and everything is, you know, mathematically it's impeccable. There's no problem with the mathematics. And now the point is that the scalar field, what is the scalar field? It's constructed out of the electromagnetic susceptibility response of the materials. And the metamaterials have very extraordinary electromagnetic responses. So here we have, let's go to Hal Puthoff. Is Hal Puthoff here, by the way? Is he part of the meeting?
No, he's not.
He's not, okay. So the point is this, we have the tic-tac. All right, now, what happened? Keith wanted to start accessing.
Oops.
Oh.
Keith is sharing his screen.
Yeah, okay, yeah, well, there it is. Okay, is there a question? Does anybody have a question with what is on that screen there?
Well, actually, John Brandenburg had a question. He was telling me on the phone, because apparently I can't unmute him. He has to unmute himself and he's having difficulty. So I'll ask this question for him. It was that, oh, someone just changed my thing. It was about diamond. He said diamond has a very high refractive index. So are you going to see effects in diamond that you wouldn't see in regular
okay,
carbon?
wait a minute. Okay, so that's, okay, it's a good question, but I got to also clarify a point. See, people get very confused. In fact, I don't know, where's James? Is that you? Am I talking to you, James? Or is that you? Is that who am I talking to? Oh no, there's Crown. That's James. That's you, Jim, right? No, that's oh, all right. Here's the point. The index of refraction, that's for light waves, right? That's for, you're talking about light wave going through diamond. We're not talking about that. That's far field. Okay, it's important. The far field's important if you want. Okay. This did you see his latest thing by Podklinov or how do you say, you know?
Podkletnov.
Yeah, okay. He's in Russia now, okay? He's working on a beam weapon, a gravity beam weapon that the Russians are paying for. And it might actually work, because the only reason I found out about this is through Robert Adnell. You know, he's on the list. Robert Adnell, he's a Canadian military historian. He's connected with the Canadian Army, military intelligence. And he sent me this thing about what Podklinov, whatever his name is, I can't pronounce it. What he's doing, it's not the rotating superconductor thing. He has something else. He has some kind of discharge being bang, and he's breaking metal at a distance, kind of like, what's John, you know, the other guy, you know, the crazy guy from Canada. What's his name again? We're having, you know, John, the other, you know.
Brandenburg?
Not that crazy guy, another crazy guy.
John Hutchinson.
The guy with the high voltage stuff, the Tesla.
Oh.
Hutchinson.
But Hutchinson, yeah. So he's getting effects like Hutchinson, okay? And that's far field. Yeah, we can, okay, look at the equation that Keith wrote down, the S. When S gets very big, okay, and if
May I ask a question?
Yeah.
This is Jose Rodal. Is S a function of space-time?
Yes, of course. It's a field, a scalar field, just like it's a zero-rank tensor field, just like the tensors in the equation. See those things? See what S is? S is the contraction of the fourth rank tensor with itself. That fourth rank tensor is the generalized electromagnetic susceptibility tensor of any material that was developed by these two guys actually in Venezuela, Medina and Stephanie. Now, Keith is worried about certain mathematical details might not be right, but the the general idea is correct. That
No, they're correct. Just one of their equations that's not relevant to our scalar.
all right.
An intermediate one is wrong, but the whole thing is right. It's all correct, Jack.
Okay, so there it is. And what Keith did, Keith just actually calculated this thing through for a homogeneous isotropic material, and that's what the scalar field turns out to be in any frame of reference, where epsilon's the permittivity and mu is the magnetic permeability. And notice what happens when.
Hey, can I have a follow-up question?
Yeah.
Okay, so S is a function of space-time.
Yeah, it's a field. It's a field.
Sorry?
Yes, absolutely. That's very important because if S was not a function of space-time, then we could not get low-energy warp drive. We could not explain the tic-tac.
So have you compared what you're proposing with our known cosmological observations? For example, for a magnetar has about 10 to the 11 Teslas.
I don't know. No, listen, that's getting, I don't want to get into that because number one, I don't know anything about magnetars, okay? It may be a good idea. I'm not saying you don't have a good idea. This is something you should investigate. But let me explain something. Let me explain something. We are very focused right now. We're very focused. We're very focused. This is military. Okay, let me explain something. I went to Cornell University, in the late 50s. My professors, Hans Bethe, Phil Morrison, Robert Wilson, they built the atomic bomb Manhattan Project. And I knew John Wheeler, I met Richard Feynman, all these people, right? Right now, we're focused on essentially a military project, because this is weapons, among other, peaceful applications. As we speak, all this information is being studied by the Joint Chiefs of Staff at the Pentagon, okay? So I want you to understand, we're focused just on engine. We're focused on only on this. I don't care about dark energy. I don't care about abstract physics. There may be many applications that if you see a connection with something else, by all means, we encourage you to work on it. But we're just focused like a laser beam on explaining the tic-tac and building tic-tacs, okay? Let's just go over the history of this, okay? I was asked by the Central Intelligence Agency back in the mid-70s, working with Hal Puthoff and all those guys at SRI. When I met them, this is a whole story. It's in the Hippie Say Physics and my book, Destiny Matrix, more details. We were asked to work on two problems: consciousness, what is the physical basis of consciousness, and how do flying saucers work, okay? We were asked to do this specifically by a guy named George Koopman, who was Army intelligence guy. And also I've been involved in this even as a kid. I won't go back that far. So I believe now that I have solved, with the help of other people, I've solved both problems. We basically understand the physical nature of consciousness, how it's generated in matter. It also involves some of Stuart Hameroff's ideas, although not his theoretical ideas. His, the microtubule stuff involves that. We think we know how to do that, and I think we know how to build these tic-tacs. Now, what's interesting is that in 1999, 2000, remember Joe Firmage? As everybody, oh well, John, you were part of it. Brandenburg was part of it. Joe Firmage, who is connected, by the way, with the Clintons. I mean, Firmage is he's a descendant of Joseph Smith, one of the big Mormons things with the Mormon money, and he made some money on the internet, but he was kind of, well, I won't go into all the details. He couldn't, John Brandenburg was there, he knows what happened. But in any case, it was called ISSO. I was the chief scientist of ISSO in San Francisco. Hal Puthoff ran it. And I forget the other guy's name, the guy that Hal was working with at the time. He's kind of a minister now. I don't even know if he's still alive. But in any case, we were working on the problem of UFOs back then already. And we had government contractors, there was government involvement and all this stuff too. But I didn't have the idea. Interestingly enough, going back over some of the ISSO reports from 1999, 2000, I have what looks like a metamaterial without knowing anything about metamaterials. What I had was a network of little LCR oscillators in a web saying this, and I don't, I was like channeling, I don't know where it was coming from. I never even heard of metamaterials. Nobody back then was talking metamaterials. And nobody in the group, Al put up, never talked about it. Nobody talked about it. We had guys from Russia. We had two physicists from Moscow who were there. We had J.P. Vigier, Vigier from worked with David Bohm, the hidden variable theory. So we spent $2 million at this defense contract. I forget the name of it already. And it came to nothing. Because there was a lot of, we tested a lot of flaky things. We had a lab with all this magnetic propulsion, all this kind of stuff. Nothing worked. And I didn't have the idea either. I mean, I didn't know what I was doing. It was basically sleepwalking. All right, so then I don't remember how it happened, but it's 2010. So 10 years goes by, it's 2010. And because I worked with Creon Levitt, turns out he became, Creon Levitt is at NASA Ames. He won the Feynman Prize for nanotechnology, smart kid, and he became second assistant to General Pete Worden, who went from USAF Space Command over to be the administrator of NASA Ames. So I was hanging out, and we had Doug Trumbull from, the guy who did special effects in 2001. So we had meetings at my place up on Russian Hill here, where I am, with Doug Trumbull and General Worden and Creon, a bunch of people. And then they got the idea to do the 100-year Starship, okay? And I was part of the original 30 people at meeting at this Fort Mason, this fort by the Golden Gate Bridge, setting up this thing with the 100-year Starship. And as a result, I was part of the original 30 people doing it. And then that led to the meeting in Orlando. And I don't remember, Keith, you were asking me how this happened. I don't remember how I got the damn idea about what you were talking about, the slowing of light in superconductors. I was very, very vague. It wasn't quite right, as you pointed out. And, but that's where I got the idea. And then I gave the paper, I gave the talk, and John Kramer was there, and Brandenburg was there, and Eric Davis was there. And they misunderstood it. In fact, and Woodward misunderstood. In fact, this book he misunderstands. He thinks some guy, I don't remember his name, he's on Woodward's list. They thought I was talking about, they thought I confused the simulation of metrics with far-field light rays going through metamaterials. The simulated metrics was just like a computer thing, analog computer representation. They thought that's what I was talking about. It's not what I was talking about. They didn't even get what I was talking about. They totally misunderstood this idea that Keith just put down. See, I was talking that. They thought it was about something else. In fact, in Woodward's book, he makes, sorry, James, but you make a totally irrelevant, comment. It has nothing to do with what I'm talking about. It's a straw man. Okay, but I was pretty vague about it too. I was at the stage that Keith wants to introduce this thing slows down in light, it's at phase velocity, group velocity, and I wasn't even clear about near fields and far fields then. But in any case, let's talk about UFOs. That this maybe can explain. I had the idea, I call it low power warp drive. That's the name of the talk. And then there was some kind of, I think it was Eric Davis, I'm not sure exactly what happened, but there was a reaction against bringing in, it said flying saucers, we shouldn't be talking about flying saucers, okay? Now this created a big brouhaha because Sharon Weinberger was there. Sharon Weinberger is a defense journalist. She wrote a book called, she wrote a bunch of books, and Sharon Weinberger wrote a big article in the BBC, was on BBC television, about how I disrupted the meeting by talking about flying saucers, that people didn't want to hear that was considered too crazy, little green men. They would see, because they're trying to get money from DARPA. This was a DARPA NASA project. So it was all politics. And then Doug Trumbull the next day gave a talk and said, kind of defended me, saying, well, yeah, he thinks flying saucers is a germane, is a relevant topic. So this whole thing about flying saucers. Now, let's skip, it's October, late October 2017. It's like 6 years later. I'm in London because I go to London frequently. I belong to a club there, and I work with some English physicists. In any case, I'm in London, and there's this Bohm Centennial meeting the Fetzer Foundation. So I go to this meeting at the University of London, Birkbeck, because I used to be a research fellow with David Bohm at Birkbeck. And guess who I meet there? I meet Hal Puthoff and Kit Green, Christopher Green. I didn't even know they didn't know I was there. You know, there we are. So we started hanging out together, and then I took them. I belonged to this club, the Savile Club, which is during World War II was called the Spies Club. We have, you know, it's MI6, MI5, GCHQ people, military, you know, the British Army. You know, that's so. Anyway, I took a Kit and I took a Kit and Hal to my club for dinner, you know, during the meeting, and then we met some other people, and then there's this woman who's pretty high up in British politics, and she took us all to the Athenaeum, which is another exclusive club on Pall Mall, and all this kind of stuff. In any case, so Hal and Kit, they were very appreciative of what I did for them, and they also invited me to some private dinner that they gave, you know, that the foundation gave only for the big shots. I was there. In fact, there's photographs of me with them. But here's the point why I'm mentioning this. The reason I'm mentioning it, while we were all these talking, every now and then phone calls would happen, and either Hal or Kit would have to run out of the room. They were talking to the Pentagon and talking this. They were setting up the release of the Tic Tac stuff. So, you know, the synchronicities are pretty amazing. See, I didn't know anything about Tic Tac when I'm talking about all this stuff. And so I think this is, so the Tic Tac, what the equation, the basic equation that Keith has written down, that explains the Tic Tac qualitatively, you know, conceptually. We're not saying we know how to make one yet because we have to find the right materials. But if you look at that, can everybody see the equation? Are you all? I can't. Okay, I can't. Did you say something, Hal? Because I didn't see. I can't hear you.
Oh, we can see the equations. Okay.
You can see the equation. Okay, now look at this equation S. Okay. It's very important to realize that S is not only a field, it's a complex valued field. It has an imaginary part. Why? Because it depends on the susceptibilities, and we know susceptibilities have real and imaginary parts. The imaginary part has to do with dissipation, has to do with inelastic scattering, right? Photons coming in, scattering off the electrons and ions, and the irreversible dissipation, that's an imaginary part. So here we have Einstein equation, which is normally thought to be tensors are real, right? The curvature tensor, stress, actually the stress energy tensor, wait a minute. The stress energy tensor for electromagnetic field has an imaginary part because the stress energy tensor involves the permittivity and the permeability, and they have imaginary parts. That's Kramer's chronic dispersion relations, causality, all that stuff. So how do you do the imaginary parts? What does that mean? Are there two universes with an imaginary curvature tensor and a real curvature tensor? But then I realized, in fact, it was something that Keith said, well, you always, and you go to Feynman, volume 1, Feynman, you know, he talks about the LC oscillator, chapter 23, Feynman, you know, you take the real part, you get a cosine thing. So, so the point is this, what dissipation is doing, it's a phase shift. It's a phase shift. In other words, think of Einstein's field equation as an electrical engineering equation, almost like Ohm's law. You have an output. What's the output? The output is the gravitational tensor, G mu nu. That's like an output. The input is the stress energy tensor. And the coupling, G over C to the fourth with our scalar field, that's like an impedance. It's like a transfer function. Think of it like an engineer, okay? It's like a transfer function. So what the imaginary part does, it shifts. There's a relative phase shift. There's going to be, in the equation on the right-hand side, there's going to be a cosine of a relative phase shift between the input electromagnetic field and the output gravitational field. This is like electrical engineering, okay? And what that phase shift does, depending on it's cosine of theta, right? Well, if cosine theta goes negative, you get anti-gravity. You get anti-gravity. So depending on the phase, depending on how you tweak the dissipation in the metamaterial, you can make the response either attractive, but what are you doing? You're sending in an electromagnetic field, and right now we're dealing with near fields, like Tesla fields, like induction, and we're dealing like capacitors. Just think of LCR circuits. We're at that level. We don't want to do far field radiation. Radiation, in terms of warp drive, is like the oil leaking from the engine. We don't want that. That's just, we want to suppress far field. We just want to do off-shell near field. Now, the frequency is not equal to the wave vector. And we're dealing with low frequency. We're dealing with almost static fields. The Earth's gravity field is a static field. It's like a Coulomb field. It's a static field. We want to cancel that. We don't want to do radiation right now, unless we want to make a beam weapon like whatever the guy in Russia is dealing with. So there's the thing. So the point is, so now look, if think of S now, it has a real amount, think of it in polar form. So think of this S as the modulus. When the modulus of S gets very big, that means for a very small stress energy electromagnetic field input, we get a large gravitational output. Okay, so that's a resonance. Whenever the metamaterial has a resonant peak, that means that we can generate, this is qualitative now, we can generate a strong gravity field for a very weak stress energy tensor of the input electromagnetic field. I call it the pump field. We have electromagnetic pump field. That's what we're talking about. We just want to, what does that electromagnetic pump field induce? So, and then by changing the relative amounts of inelastic to elastic scattering, which you can do in metamaterials because they're artificial atoms, you can just sort of do anything you want, okay? And we can make it go either from gravity to anti-gravity in each, and I'm talking about in each meta-atom in a lattice of meta-atoms, okay? Think of the Alcubierre warp drive. The Alcubierre warp drive has different amounts of attractive gravity and repulsive anti-gravity at different points on the fuselage of the starship or the ring, whatever, that torus arrangement that it has. You've seen some of the designs. Okay, so you have to be able to vary whether you want locally, if you want an attractive gravity, do you want a repulsive anti-gravity at different parts of your fuselage, you want to be able to control that individually. And that's what I'm talking about. We're talking about each, the pump, the electromagnetic field is pumping each meta-atom in the metamaterial. Now, okay, one other thing. If you look at the To the Stars Academy, okay, which is has all these spooks in it. Chris Mellon, who was Assistant Secretary of Defense for Intelligence during 9/11. He didn't do a very good job, but unfortunately. But
yeah, can I interrupt just one brief second? I have to leave now, so I'll leave this up on the notes. Yeah. You guys can do whatever you want with it. I can send you the notes later. I have to leave though now. I have this appointment at 11. I forgot. I have to actually be there at 11. So I have to leave now.
Okay. So, all right.
God bless. Nice talk. Keep going.
Right. Okay. Thanks, Keith.
Okay. Now, so what was I talking about? Okay. So Hal Puthoff, if you look at Hal Puthoff's talks, he has a bunch of talks. They're all empirical. And he keeps talking about metamaterials. But they have no idea how the metamaterials are useful for their propulsion. They don't have this idea that I'm talking about. I tried to explain this to Hal in London in late October of 2017. It wasn't as clear to me back then as it is now because working with Keith Wanza has made it a lot clearer. And I wasn't sure if Hal really got it, okay? And I got to say something about Hal. I've known Hal Puthoff since 1973. Hal Puthoff and Russell Targ, when we got involved with the whole CIA remote viewing stuff. And that's all in how the hippies say physics. And you have to remember that Hal has a PhD from Stanford. He was an experimental laser physicist. He's not a theoretical physicist. Hal is very good for like what they're saying to test the metamaterial. He's a lab guy, he's an experimental guy. And so, and also his paper, the paper that they always quote, the PV, polarized vacuum paper, it doesn't even address the issue. What Hal does in that paper, what he does is basically correct. What he does is say, okay, you have Commander Fravor is sent out from the Nimitz, and he sees this tic-tac. Okay, what Hal's paper does is sort of tell you what Fravor or what the FLIR and what the radar on the Princeton, it's sort of saying what the distant observer sees under different conditions. That's the only, there's nothing in Hal's paper saying, well, how do you generate this warp field? He doesn't have a clue about how to do that. And he has no clue about metamaterials apart from what I'm telling him, which I'm not sure if he's understanding it or not. So that's a big gap there. But what disturbs me is that when they go on television and they do, you know, unidentified on History Channel, these distinctions, these important points are not made. So they're giving the public the wrong impression that they kind of understand what they're talking about when they don't. They don't really have a clue. All they know is sort of what the thing would look like from the outside, you know, from electromagnetic signals coming from the device, but they don't know how to generate the warp field. And that's what I claim that Keith and we basically know how to do that. I should mention another thing.
Jack?
Yeah.
I have more, this is Jose Rodal again. I have more questions, but there is a question here from John Kramer that is posted in the group chat for you.
Okay.
And I'm going to read it to you. John Kramer, yes?
Yes, go ahead.
Yeah, John Kramer asks you, does Sarfatti's anti-gravity imply negative inertia?
No, inertia has nothing to do with anything. Okay, I'm glad he asked that question. Whenever I hear the word inertia, I reach for my delete button. Okay, all right. Inertia has nothing to do with anything. What does it know? You mean, first of all, define what, do you mean the rest mass of the tic-tac? Let's be very specific. We're talking about a military problem here. Okay, it's like we're in the Manhattan Project. We're trying to make an atomic bomb. Right now, we're trying to build a tic-tac. By inertia, are you talking about the rest mass of the machine? Is that what you mean by inertia? What do you mean?
He didn't say. That's the question he posted was, does Sarfatti anti-gravity imply negative inertia?
I don't know what he means. I don't understand the question. Look at the equation. Look at the equation. Okay, we go back. What does he mean? You know, I asked, does inertia mean the mass of the ship? Is that what he's talking about? Well, does he mean the stress energy tensor? Do you mean the stress energy tensor?
We don't know. That's all he posted.
Yeah, okay. Well, the question, you know, it's too vague. I don't know what the question is. I don't understand the question. Can we get back? How do we get back? Okay, okay, look. I wish you could get back. Can anybody move that note thing to get to the line above it, the Einstein equation? Okay.
Fortunately not.
Okay, all right. So here's the point. The point is, S has a cosine in it, has a phase shift. Well, just think Einstein's equation. Inertia, I don't know what inertia doesn't get into. What is Einstein's field equation? There's a stress energy tensor source, which is electromagnetic field in our case. It's a pump field, electromagnetic field source. And there's an output, the warp field, the local gravitational field generated. It's a local partial differential equation, a tensor field equation, right? So it has, you put in a stress energy tensor, you multiply it by S, and you get an output, a gravitational field at that point, okay? When the cosine is negative, it goes from gravity to anti-gravity. What does inertia mean? Also, we're talking about warp drive is geodesic. The equivalence principle and the rest mass of the particle that's following the geodesic is irrelevant. The Einstein equivalence principle. Okay, so what I don't know what inertia means in this context. I have mathematics here. I know what I'm talking about. I don't know when they talk about inertia. Now, one thing. Let me make an empirical thing. It's easy to tell in principle if a flying machine is in warp drive or not. Guess why? Because it has the reverse Doppler effect. If you look at the Alcubierre warp, if you look at Alcubierre's thing, suppose the tic-tac's coming toward you. Okay, let's get very specific. You're Commander Fravor, you're in the F-18, and you're in a dogfight with tic-tac. This is what I'm talking to the Joint Chiefs of Staff at the Pentagon about. So this is real, okay? This is what. Okay. So the tic-tac's coming toward you, and you have radar, you have the latest thing, but your radar can detect frequency shifts, okay? If the thing is coming toward you at what appears to be high speed, but you see a red shift and not a blue shift, that's warp drive. You got that? Because what's happening in the Alcubierre case, in the nose of the starship or the tic-tac, in the nose of it, space is contracting, and that corresponds to gravitational redshift. The gravitational redshift acts opposite to the Doppler, to any, if there is a Doppler thing, that's another point. We're not sure if there should be even a Doppler thing, but if there is a Doppler shift, it'll be canceled. It tends to be canceled by the gravity redshift. But in the tail, if the tic-tac is running away from you, if it's running away from you, instead of redshift, you can see a blue shift. You can see the anti-gravity blue shift because space is expanding there. The anti-gravity expands space and it causes a blue shift, gravitational blue shift, just the opposite, redshift. Okay, now, here's the thing. Here's something very interesting. An important thing with Hal Portoff has been saying. If you go to Hal's talks that are online, his PowerPoint presentations, toward the end, in fact, the very last slide, he's talking about the harmful, deleterious effects of UFOs with contactees. Talk about that they get radiation burns. In fact, this is even happening at the Skinwalker Ranch. If you read the skin, that port, they have a portal. They have like a tic-tac hovering above in the Skinwalker Ranch that Brandon Fugel has taken over from Bob Bigelow. It's all on History Channel. They're reporting these like ionizing, like the radioactivity effect. Well, that's the blue shift. That's the warp drive blue shift. In other words, if a tic-tac, if a flying saucer is hovering, still just hovering above you, in order for it to hover, it has to generate an anti-gravity at its base, and that's a blue shift, and that blue shift can cause just ordinary photons to become maybe ionizing radiation. So that all fits, qualitatively it all fits, okay? So we're able to explain a lot of things just qualitatively. Yeah, that's what theoretical physics, the way, I was trained at Cornell with Hans Bethe. Hans Bethe was my senior, thesis advisor. Peter Goldreich was in my class, and so, we learned how, the Cornell philosophy was try to explain as much physics as you can with the most elementary mathematics that you can. And that's what I've done here, that it's all plain vanilla Einstein gravity theory, Maxwell's classical electrodynamics, a little bit of solid state physics, quantum mechanics, very elementary stuff. And it qualitatively explains everything we're seeing. Okay. Any more questions?
Yes, can you hear me? This is Jose Rodal again. Somebody put an equation on top of your pad there, and I want to check whether you agree with it. They put a coupling constant there that does not have S.
Well, that's the whole point. Then they don't understand what the hell we're talking about. Yeah, you have to have an S. That's what we're putting in the S. That's
okay,
stupid.
So
it's like I'm talking all this time and whoever wrote that doesn't understand a thing of what I've been saying. That's frustrating.
Right.
That's frustrating. They don't get it. They just don't get it.
Okay, so, the equation should be S there.
There should be S there, yes.
And that question is, the equation they wrote has the Ricci tensor. You're proposing to have the scalar field S on the coupling constant, and you are preserving the Ricci tensor on the left-hand side of the equation?
Look, everything is the same. All this is an S. Why is that? This is so simple. Why does this guy understand it? But just put the S in, multiplying the G. Okay, or put the S in front of the T mu. The S is the response of the metamaterial. It's the electron. The TUV is a pump field. It induces a response in the metamaterial. When that response gets big, well, okay, you write it better. And that's what I've been talking about all along. What does this guy think we're talking about? He didn't even understand what Keith was saying. We're using Einstein's equation with this modification from the metamaterial. See, most materials, the index of refraction is 1, close to 1. It's only in these metamaterials that you get these huge changes in the response of the material. Okay? So the reason it hasn't been noticed, except what Potnikov, whatever it is, and who's the guy, the Italian guy who worked with Poletnikov, the Italian guy, can't remember. Modenese, yes. Well, okay. You see, everything we're saying, it's quite consistent with what Modenese and Potnikov are saying, because if you look at the equation, you see mu, the superconductors are diamagnetic, the Meissner effect. So mu goes to 0 there. So S gets big. This is what the first thing Keith noticed. Keith, this is Keith 1. Yes, that's it. But that's what we said at the beginning. That's what Keith wrote down. Keith wrote that equation down. It's right above this thing here, if we can move it. That's the equation Keith wrote down.
No, no, hold it a second. Now they put the S also on the left-hand side. I don't think.
No, that's stupid.
They replace the original scalar by.
No, that's dumb. That's dumb. The guy doesn't understand the physics. Who's ever saying this doesn't understand a thing, okay? The S is from the response. What the physics is, he's not doing mathematics. He's not balancing equations. That's stupid. I mean, pardon me, but I get frustrated at people who are really dumb. They don't get things. I mean, the most elementary thing, it's hard for them. So I'm speaking to a bunch of, I'm sorry. I apologize, but I have an Italian temper, okay? Right. Now, the point is, the physics is you shoot photons into this metamaterial. The metamaterial is full of charges. Those charges respond strongly, and that response to the input photons, that appears only on the right-hand side. You don't multiply on the left-hand side. You're inducing that. That's the output. It's an input-output. It's a response function. It's like engineering. Okay? So if you can't understand that, it's like I'm talking to a wall. I'm talking to Joe Biden. He doesn't understand anything either. Talk to him. He just, I mean, so, now, does anybody understand what I'm talking about?
Yes.
All right.
Yes. Cool down. Let me ask you a question so that you cool down. All right. So you have introduced the scalar field S.
Yes.
So
force field. What it's doing, okay, it's basically renormalizing the stress energy tensor. It's it's quantum field theory. You have a bare charge and a couple, see, you have the virtual photons dressing it. Okay, when you stick an external, from the outside, you stick an electromagnetic field inside the material, this polarization and permeate, it changes the stress energy tensor. So you can think of S as a dressing or renormalization of the kind of the stress energy tensor of the electromagnetic field that you put into the material. It's a pump field. By the way, there's something else I haven't even mentioned. There's an additional effect, but I think it's going to be too difficult to try to explain it because I can't do the mathematics here. I can't. Okay. There's the Froelich effect. This is the Froelich. There's an additional effect. There's an additional effect in which S has an exponential dependence on the Froelich order parameter, which is like, this is the connection with Modenese. Modenese is saying that the gravity is enhanced in superconductors because this is the macroscopic coherence factor. S has an e to the psi. Just imagine S is being multiplied by an e, an exponential, to the psi in the exponent. The psi is the Froelich, it's a dimensionless, it's a complex field. It's a Froelich order parameter. Okay?
Yes, of course.
This happens when you pump the material above it. It's like a laser. Okay, it's analogous to a laser. The Froelich effect is basically laser physics, like he did it for biological membranes, for things like microtubules, stuff like that. But it's basically the laser. If you pump the material properly above a critical threshold, you can get this coherence effect. And that makes the response, the gravitational response, even stronger than what we've been talking about, even stronger. See, there are two levels here.
All right, so S stands for the Sarfatti scalar field.
Yes.
And this is new. If one goes to any book on general relativity, the scalar field is not there.
Get books on, you know what you do? Okay, I don't want to be sounding like a Nazi. You burn the books. Burn the books.
All right.
Let me tell you something.
No, no,
Let me explain something. Is you go to any book, okay, let me explain. Let me be serious. Let me be serious. The guys who do general relativity, they're mainly pure mathematics types, okay? One of the first, even Kip Thorne, who's kind of the best of them, they said at the beginning, they said G equal 1 and C equal 1. They never even consider the material. They don't even ask the question. It's not even their mind. It's not in their mind, okay? They're not thinking like engineers. So everything with general relativity, or everything that's in the books, it's fine, but it has to be redone with the, you know, in this new case. I'm talking about a new phenomenon, a new situation. They didn't have Einstein didn't have metamaterials. He didn't need any of this stuff.
Fine.
They didn't have a tic-tac. It's a new phenomenon.
So this is a new scalar field. Now, just like for whenever we advance science, for example, when Einstein came up with the general relativity theory and replaced the Euclidean background by a pseudo-Riemannian, we had to check it, what the theory predicts versus actual experiments.
Yes.
And it is hold on a second. And how do we do an experiment in general relativity? Well, we look, for example, at the precession of Mercury and whether the theory can predict it. What I propose is, in this case, we have this scalar field here.
Yeah.
Shouldn't we see whether it is compatible with our measurements? And in this case, I think cosmological measurements. If we have
no, there's no S there. S is 1 there. You're wrong. Whoever says that doesn't understand a damn thing I've been talking about. The S in vacuum is 1.
Yeah,
it's
but
only inside a material, a special material. It's only inside an artificial material that we make. It doesn't exist in nature.
But in a
there may be. Wait a minute. Okay, I'll back off a little bit.
Let me ask that question. I'm not talking about the vacuum. If we have a magnetar, right?
Okay, don't ask him. I don't know what a magnetar is. You may be right. Well, whatever you say, you go. I said you go study it and you tell me. Don't ask me a question about it, something I don't know about. I want to stay on track here. You may have a good idea there, so go investigate it. There may be evidence. Yeah, maybe if it's a superconducting, a neutron star, if it's superconducting state, it'll have some weird effects and it may explain data. That's a good idea, but I don't know anything about it, so I don't want to waste, the limited time here. I just want to talk about right now, tic-tacs. We're talking about a weapon system. Okay, let me say something else. See, the Russians came and interviewed me about all this. Soon after the FSB, the Russian military intelligence, of course, they were at the Orlando meeting in 2011, right? They're not going to miss that. Okay? They're not going to miss that. Also, the Russians know about, because if you go back to how hippie safe is, I actually helped formulate Strategic Defense Initiative working with Reagan think tank people at the Institute for Contemporary Studies. That's a whole story. So, and we were actually talking with high-level Russians. This is back in the early 1980s. Okay, so the Russian intelligence has been very aware, and of course they follow Hal Puthoff and all this stuff. And Uri Geller, a friend of Uri Geller. I mean, so the Russian intelligence. I'm a known quantity of Russian intelligence. So what happened soon after, about a year or two after the Orlando meeting, I get a phone call. They're allegedly this guy Vladimir, and they're from St. Petersburg, Channel 5, St. Petersburg. They like to video me for a program. So they came. It's about 3 hours, and everything I was taught, the primitive ideas I had then about the low power warp drive that came up, and consciousness and conscious computers, all this stuff, and so the Russians know about this. And then in June of 2016, I never heard from them. They said they're sending. They never heard from me after this. So, and by the way, I have friends in the CIA. They knew about it. I reported all that stuff. Jim Angleton and Ron Pandolfi, those guys. So they knew about this. So then it's June 2016. during the election, and these Russians call me up again, and they say they want to video me again about the election. I don't know why they're asking me about the election. Well, I sort of do know why, but says okay, and because they were doing a show on Trump's 70th birthday. And they asked me all kinds of political questions. I said, what, because I happen to know people, I work with people who were friends of Trump, so then they knew this. Obviously, you know, they know what they're doing.
Jack,
Yeah. So, but let me just explain. So they asked me, but here's the important, they asked me a bunch of things, and this you can see on the internet. This is actually, you can see me, you can see them interviewing me on this show about Donald Trump's election. This is for June of his birthday. But here's what they said. As the guy was leaving, he said, I don't know, Jack, but they really like you in Moscow. Okay. That's what he said. So, yeah, with the kind of a wink. I really like you in Moscow. So what this means, and the way I take this, the Russians are very. There was also there's some guy Zeldovich, some guy. There's a bunch of Russians that communicate with me. Some guy they want to translate all my stuff in physics into Russian. I said, yeah, go ahead. I don't care. Go ahead and do it. So the point is, the Russians. My ideas are taken very seriously in Russia, in Moscow. Okay. And so the point is, there's a race. We're in an arms race right now. The Russians have a heads up on this, and they have been working on this actually for a couple of years, and they're not stupid. Okay, so that's why there's a sense of urgency about this, that we have all the pieces, and I think the To the Stars Academy is actually an obstacle to getting the job done. All right, other questions? Go ahead.
yes. What is the characteristic wavelength of this effect that gravitational effect that you're expecting?
What do you mean characters? It depends. We want to do static fields, wavelength's infinity. The wavelength's infinite, well, a little big, and the frequency is small. It's a near field, it's a static field. What's the wavelength of the Earth's gravitational field? Same thing. What do you mean the wavelength? You mean whatever it is, there's no unique wavelength. It depends how you design the thing. It could be anything you want it to be. We're talking about near field. Frequency is the frequency is not equal to the speed of light times the wave vector. That's for far fields. That's right. For radiation. I'm not talking radiation. I'm talking about the electromagnetic field we put into the metamaterial is a static. It's like it's from a condenser and it's like an LC oscillator, but oscillating at very low frequency. It's that sort of thing. It's an induction field we're talking about, and we're going to induce gravitational induction fields. We want to cancel the Earth's gravity field. It's like a static field, right?
Right.
So the question, what's the wavelength? Well, it's another stupid question. Sorry.
Jack, it's Jack?
Yes.
For me, it's George Hathaway here.
Yeah.
You mentioned redshift in conjunction with tic-tac. Is there any evidence that FLIR or other observations detected a redshift?
Okay, well, I asked Cal Puthoff and asked, Eric Davis says they don't have the capability. So this is a prediction. Sarfatti is making a prediction, a very practical prediction. Now, Doug Trumbull does have the devices, at least back in Doug Trumbull put his own money into, he has portable, they're on Jeeps or something, he has a portable, SUVs. He has all this equipment. He says he can measure Doppler shifts. He can do all that. But I know he was sick. I don't know if he's still, how he is right now, but I think he had cancer or something, whatever. But this is back in 2010. So what I would do was, apparently FLIR, I don't know, because I don't know the details. I'm not, that's not my field. But this is a Sarfatti prediction. You make the equipment. In fact, Hathaway, you can make you have that equipment, right? There's only one guy who claims to have seen this. One guy, that's Bruce Cornett for sound waves. See, this should be universal. It's gravity. It's the warping of space-time. So all waves, whether they're light waves or sound waves, will have this effect. Bruce Cornett, I don't know how reliable he is, claims to have seen this very effect with sound waves and flying saucers that have been that he's measured with his acoustic equipment. He's some kind of, he's a geologist and he has acoustic detectors. I don't know, but Cornet claims to have seen this.
Okay, thank you. One other question.
Yeah.
In the cos theta between the stress energy tensor and gravity,
Yes.
Is theta, in your opinion, a real angle, or what is theta?
No, there's a bunch when you go. No. What you have, it's not a real angle. No, it's not a physical angle. It's if you just look at the stress. First of all, the stress energy tensor is going to be pretty complicated for a real metamaterial. It's anisotropic. It's inhomogeneous. You have all these different, cross fields. An electric field here. Electric field will also generate a magnetic field. Even a static case. There's all this complicated stuff. You look at. There's a good paper by Medina and Stephanie called the electromagnetic stress energy tensor in matter, and they have all the complete details. I have the 4th rank tensors we're using. I'm using their paper. Okay, so and since the electromagnetic field stress energy tensor involves the susceptibilities, they have imaginary parts from dissipation. It's just inelastic scattering, and so we have complex complex permeabilities, complex permittivities in the stress tensor, and they're also in the coupling constant. So you have a whole bunch of, it's non-trivial. It's non-trivial to actually do the algebra, do the complex algebra. What you have is a product of a lot of complex functions, the amplitudes and phases. You have to keep track of all of them, multiply them all together, and you get a net phase shift. It's a phase shift in time. It's just like an LCR. It's just like an LCR pumped out. Just go to Feynman. Go to Feynman, chapter 23, volume 1. Okay. He talks about the phase shift and dissipation. That's what it is, but it's much more complicated. It's a much more complicated thing. So
thank you.
It's input, output. You're an engineer. You have an input signal and an output signal. There's a phase shift that's mainly in time and maybe space too. Okay.
Oh, Jack, is this the paper you mentioned?
Yes, that's the paper. Yes.
Okay, cool. So
everything
you find it easily on the archive. Just look up energy momentum tensor electromagnetic fields.
Yeah. That's the paper. That's the paper.
I've got it in the chat thing. I just put it up.
Yeah.
Okay. We're actually getting very close to the hour now for the next talk. Yeah. So thank you very much indeed, Jack, for doing this very short notice. I really appreciate it. And if you'd like, I'd definitely put you on the list for next year if you're interested in the Estes Park Advanced Propulsion Workshop.
Okay, before I close, let me just say that there's a group of us. I'm working with, Nick. You know who Nick Cook is. He's kind of on the periphery. I've been meeting with Nick Cook, and there's this guy Maurice Passman who worked with James Moffett at the Ministry of Defense. He's a PhD from Birkbeck College. He's working on it, and we're working with an officer from the Italian Air Force and people in Italy. There's a big interest in Cortona, and they're actually trying to get money from the European Defense Organization, to fund this work. I mean, it's taken very seriously in Italy and also in England. And I am communicating with the Prime Minister's office in London about this too, through to my connections with in the club world, the private club world of London. So this is there's an arms race right now. This is this should be taken very seriously, and I'm really focused on making Tic Tacs. And this thing from Russia, the Podglednikov, this thing with the beam weapon. See, that's okay. Let me just end with this. We can also make high energy, high frequency gravitational waves with the same effect. But it's a different it's a different area of we can do that. And that could be a weapon. And it looks like the Russians maybe are working on that.
Are you aware of Ray Chow's work and his work on the...
I know Ray Chow personally. I used to go to his classes in Berkeley. Yeah, Ray Chow. Yeah, in fact, yes. In fact, I'm glad you mentioned that. Is he still around? And is he?
Oh yeah, he's still around. He's doing experiments still.
Yeah. Okay. Well, Ray Chow, of course, I'd love to get Ray Chow involved in this because, in fact, some of his ideas are very close to what I'm talking about. Superconductors and enhanced gravity. Yeah. It's all everything Keith Wands and I are doing fits with Ray Chow and fits with Modnazy and Podglednikov. I can't pronounce his name. And now it looks as though if you check with Robert Adnell, he has the information on these gravity beam experiments that they claim to be doing in Russia, where they're actually breaking up metal, like the Hutchison effect. So this is serious stuff.
Okay. Now, I should also ask you, I've been recording this. Is there anything that you've said that I shouldn't put online?
No, put it all online. I want it. I want Tucker Carlson should be talking to me and not talking to the guys he's talking to.
Okay. Well, in that case, thank you again, Jack. Really appreciate the very short notice and you stepping in. I really do. I appreciate that a lot. And now I really should introduce our next.
Screaming. Okay, all right.
Oh, and by the way, I was the idiot that put up the line on the equation. I just wanted to put. I couldn't remember what Keith had written, so my bad.
Keith wrote that equation with S in it. That's all.
I know. I just forgot where the S went, so I put it up. I knew you'd tell me that I was wrong. So
you're forgiven.
Thank you very much. Okay, so I'm going to.